Hello and welcome back. This is part 5 of Ted Brown's InnoCentive Challenge Solutions review for the years 2014 through 2023 that I wrote solutions for during that period. And it's March the 10th, and we'll take a look at this one at a time. This first one is optimal biogas utilization, is the challenge title, and I wrote this and submitted it in July 18th of 2019. So we're getting into the years 2019 through 2020 in this slide deck. We're moving right along. The proposal title is Energy Efficient Pressure Enhanced Mass Transfer of Biogas in an industrial scale bioreactor to produce liquid butanol biofuel using loop reactors in an array of concentric U-tubes. Now, biogas in this case means a mixture of not only methane, it's mostly methane, it's 65% methane, but there's also some carbon dioxide and a little bit of hydrogen sulfide in it, because the seeker or sponsor in this case is related to the dairy industry. So you can imagine where the biogas comes from. It comes from an anaerobic digester that takes the dairy waste and anaerobically digests it, and the result is this biogas. But when you combine the biogas in this reactor that is in the proposal with added oxygen, and you add the right microbes, then you can theoretically produce butanol, which burns really well, just like gasoline. So it's a liquid fuel that you can put it in a pipeline and move it around. It's not as volatile as, let's say, ethanol or methanol. And it's very useful, but butanol is, and it burns pretty clean. So this just describes how to go about doing that using concentric U-tubes or loop reactors, where you have 4 8-inch diameter inner pipes placed within an outer pipe having a diameter of about 24 inches. So the inner pipes carry water and injected biogas and oxygen downward at a water velocity that's at least 10 times greater than the rise velocity of gas bubbles. So the gas bubbles basically can't rise up to the top. They're forced down into the depths of this structure, and then you have high pressure of about 50 psi at the bottom of this thing, and water is pumped down through the top of these pipes, the 8-inch pipes, with several water pumps, and you've got a culture basically of microbes that convert the ammonia, I'm sorry, not ammonia, but methane and oxygen into butanol. So you can stop and pause this, and let's go to the next slide. And this one was written in September 14th of 2019. The seeker here or sponsor is looking for innovative solutions to reduce the maintenance cost of public lighting in cities. So what I've proposed here is a smart system of unmanned aerial vehicles, also called UAVs or drones, and modular luminaries, that is streetlights, for maintenance of public lighting in cities to reduce the cost and to increase worker safety. And it's pretty self-explanatory. It's basically using drones that can fly up and replace the street lights if the whole thing is properly designed. So there would be standardized modular luminaries that can be locked and unlocked by an electronic signal. Um, and the drone would be able to remove the malfunctioning street light and replace it with a new one without somebody having to go up there and do the same thing. So basically, it's a flying robot, the drone is, and it can be repaired on the ground right there at the site, or it could be taken to a maintenance facility and worked on. You can pause this now and read the whole thing, or we'll go on to the next slide. Okay, this one was written in October 10th of 2019, and the challenge title is Innovative Sustainable Soil Remediation Methods. And this particular situation calls for remediating petroleum hydrocarbon contaminated soils that may be quite a depth down into the ground. And so my proposal title is Logistics for On-Site Myco Remediation of Petroleum Hydrocarbon Contaminated Soils. Now, what is myco remediation? That's basically inoculating a soil or a contaminated material with certain types of fungi. And in this case, it's called the white rot fungus, and it is capable of breaking down, decomposing petroleum hydrocarbons in contaminated soil. So the way to do that here in this proposal is for the soil to be excavated in a very precise manner and to be delivered to the surface um, as a cleanup technique and adding it to a medium of moistened organic materials such as sawdust or similar granular lignocellulose substrates such as wood chips or crop residue such as chopped straw, which has been previously cultured with a white rot fungus. And the advantages of this is that instead of it taking 2 years to sufficiently reduce the petroleum hydrocarbon content of the contaminated soil down to 750 parts per million or less, the myco remediation process offered by this proposal should require no more than 6 months, which is a good advantage. So you can pause this and have a look at it, or we can move on to the next slide. Okay, this one was written October 26th of 2019, and the sponsor here is looking for a way to utilize waste rock and filter cake from coal-fired plants. My proposal here is titled Beneficial Use of Waste Rock and Filter Cake, Coal Mining Byproducts, combined with flue gas desulfurization and fly ash solids from upgraded coal-fired power plants. Now, we still have coal-fired power plants around the world, and they have certain waste products, but they can be used usefully, put to good use. And in this case, I propose that you can help construction of road pavement, which requires large volumes of materials, and these can be combined in such a way that beneficial reuse could be accomplished. This combination of several categories of waste from the coal and energy industries has a very attractive kind of synergistic environmental and economic potential, because this offers an opportunity to use one kind of waste to help reuse and render beneficial and useful another kind of waste, both of which kinds of materials originate from the coal and energy industries. This is a preferred alternative uh, from both environmental and economic standpoints to that of just disposing it in a landfill. The organic matter and the moisture content of the waste rock and filter cake materials from coal mining operations are intrinsically favorable for use with flue gas desulfurization waste and fly ash solids. Um, they can bind well together to form a road-based material that is superior to the use of just one of these types of waste materials alone. So you can pause this and read the whole thing in detail, and we can move on to the next slide. Well, this is one of my more favorite ones, probably in my top 10 of the proposals that I've written up. Um, this started out with a certain European energy company, really good people that I've had a chance to talk with on the phone. But this one is about extracting lithium and possibly other valuable minerals from geothermal brines that are brought up in the process of extracting energy from geothermal sources. My title is Reusable Selective Ion Sieve Lithium Titanate Spinel Oxide, or LTO, on porous granular polymer media for extracting lithium from geothermal brine. This proposal involves an ion sieve material, an analog of metatitanic acid, expressed as tetratitanium pentatitanium dodeca oxide. So you can see the chemical formula there. And that would be infused into and onto the surface of a porous granular polymer media, or beads. And these beads are much larger than the actual LTO nanoparticles themselves. LTO is widely produced. It's more practical and less costly than other nanomaterials for selective lithium-ion sieves. Lithium titanate spinel oxide, LTO, is the preferred ion sieve for this proposal. It's used already as an anode material in lithium-ion batteries. You could recycle lithium-ion batteries to recover the LTO in bulk, which could be a cost-effective source of starting material for the lithium-ion sieve material described in this proposal. It's a powder with a specific surface area of around 30 to 33 square meters per gram. So it's high surface area. And LTO can be incorporated into a reusable ion sieve material in which acid treatment will form the desired form of LTO, offering an efficient means of lithium extraction from an aqueous solution such as geothermal brine. LTO is an attractive adsorbent for selective lithium ion extraction with superior advantages, including high ion adsorption and exchange capacity, with a high selectivity for lithium. And it's highly stable. It has high stability. It's relatively environmentally friendly and economically efficient. So the infused porous granular substrate could be polyacrylamide and various variants of that are cross-linked. So we'll need a good organic chemist, a polymer chemist, to fine-tune the cross-linking of the polyacrylamide. The polyacrylamide is known to be highly absorbent of water. If you start out extruding small 0.3 to 0.7 millimeter beads of this, when they're submerged in water, they expand to a 2 millimeter porous bead. They absorb a lot of water. And the inverse suspension polymerization method described for producing cross-linked polyacrylamide can be used with added LTO nanopowder. And before hydration, LTO will make up 40 to 50% of the weight of the mixture, forming a very stable cross-linked polyacrylamide polymer LTO composite. Now let's see if we can go to the next slide that shows us some pictures that might help illustrate this. So here we have the proposed reaction itself, the InnoCentive ion exchange reaction, which involves lithium absorption, adsorption, and acid treatment to liberate the lithium and collect it. So the lithium from the geothermal brine is adsorbed and then concentrated and then washed off with an acid treatment. The image on the right that you see is kind of an imaginary vision of what the porous polyacrylamide beads might look like. So let's go on to the next slide. Please contact me, by the way, if you're interested in this. I can be contacted by my YouTube channel or my Facebook channel or on the X platform. Okay, this one was submitted on January the 10th, 2020, so we're into the year 2020 now. We're moving right along. And the title of the challenge is Producing Glass Wool and Insulating Building Materials from Wind Turbine Blades. My title for this is Aerogel Fiberglass Composite, GFRP, using fragmented fibers and fine particles from recycled wind turbine blades that can form strong, flexible, and durable insulating building materials. This one is fairly straightforward. The idea is that, you know, at some point in time, the wind turbine blades made out of fiberglass have to be retired for mechanical and safety reasons. They have to be taken down and no longer used. It takes a couple of years of them being used, but after a while, they have to be replaced. So one way to recycle that useful material, that fiberglass material, is to first pulverize the composite fibers and fine particles made from old wind turbine blades, and then to use that to make a fairly strong, resilient, and durable insulation material, wherein the fiberglass particles and fibers from the pulverized result of recycling can reinforce an aerogel matrix. So silica aerogel is one of the best insulators that's out there. And to give it more structural strength, then this fiberglass material coming from the wind turbines can be used. So just pause that and look at the entire proposal. If you have any questions, please contact me. This was written May 18th of 2020, and we were in the throes, the entire world, the planet Earth was in the throes of the coronavirus outbreak, and it was pretty serious, and it still is, because coronavirus continues to be out there in the world. There's a number of coronaviruses, but this particular one was quite a challenge to the world for a number of years, and I guess it still continues to be. But the seeker here was just asking people's opinions around the world. What should we do to better treat coronavirus? We need to know more about its pathology and the human body's response to it. So I threw in my opinion, and I called it ranked knowledge-based directives to better treat coronavirus, adopting prophylactic and therapeutic interventions independent of forthcoming RBD vaccines against coronavirus 2019. So I've got a list of 10 things that I suggested because I suspected at the time, and it's been some years since this has all evolved and transpired, but I suspected at the time that it might take 12 to 18 months after discoveries of certain vaccines before they were universally or nationally approved and available to general populations. But in the meantime, we should learn as much as we can about this, and including looking into things such as furin inhibition and lactoferrin treatment, and the fact that it is neuroinvasive, and that we shouldn't just look at coagulation and blood clots and that sort of thing. Although those are critical and key, but we need to look at the whole human body, every tissue, every single tissue, and how it affects every single tissue, and look at inflammation biomarkers, and how they evolve over time as the virus infects the human body. And yes, I advocated or suggested continuing research, investigation, and randomized controlled clinical trials of hydroxychloroquine. I did not mention ivermectin here in this particular one, but that's probably a good idea as well. But the point here was to continue research, to continue inquiry into different areas, to see how this virus and the human immune system interacts. So you can pause this and have a look at it, and we can go on to the next one. Well, this one was written in May 4th of 2020. The challenger, or the seeker, or the sponsor, was looking for innovative survey techniques to detect small, shallow archaeological finds over large areas. And I had proposed something sort of similar to this for finding things like sinkholes and soil erosions and so forth. So this proposal that I have here is very similar to what I had proposed before for other challenges. And my title here is Detecting Small, Shallow Archaeological Finds Over Large Areas with Tier 1 Aerial Surveys and Tier 2 Ground Level Frequency Domain Electromagnetic Method, or FDEM, standardized arrays. So you can use this method for both trying to find voids and potential sinkholes in the ground, but also for archaeological sites. And it's pretty self-explanatory. The Tier 1 is LiDAR, or infrared thermography technology, taken from a wider area, that is an aerial survey. And Tier 2 is the frequency domain electromagnetic method, which you do on the ground by one or two technicians in just a few hours, very rapidly. This is not ground penetrating radar. It's FDEM, which I think that would be very effective in getting down to less than a meter resolution of what's near the surface, on the surface, or just below the surface. So you can pause this and we can go on to the next one. Well, this is another proposal that deals with my idea of combining solar and wind turbines, because the seeker here, the sponsor, is looking for future innovations of the U.S. electric grid. I sent this in May the 29th of 2020, and my title is Out of the Box Integrated Solar and Wind Innovations Focused on Availability and Flexibility for Decentralized Utility Scale Renewable Energy Generation. It's emphasis on decentralizing. We can have many of these around the country, closer to cities so that there's less transmission line losses. And I just want to emphasize that this proposal, which is, I've repeated it with other solutions, it's basically the same. It's combining solar and vertical axis wind turbines. And I just want to summarize here the utility scale energy capacities for both wind and solar. For utility scale wind power capacity in kilowatts per total land area, it offers 100 kilowatts per acre, or 250 kilowatts per hectare. For energy generation per year per total land area, it offers about 25 watts per square meter, which is pretty good. The capacity factor becomes higher because of the low cut-in speeds due to the wind scoop factor, where the PV panels are funneling wind into the vertical axis wind turbines. This represents 0.89 gigawatt hours per year per acre. So what does that mean? This represents an order of magnitude, at least a factor of 10 increase in wind energy generation per acre compared to the status quo. That's what I want to drive home here. For utility scale solar PV power capacity in megawatts per total land area and number of photovoltaic panels per total land area, it offers around 0.3 to 0.36 megawatts per acre, or 0.74 to 0.88 megawatts per hectare. So there's more PV panels per acre or hectare. And what that represents is a 2.5 to threefold increase of solar photovoltaic power capacity per acre. And it's about 1.5 times the photovoltaic energy generation per acre. So the proposal is an increase over the status quo. It offers more photovoltaic panels and turbines per acre, using more of the vertical space. It captures more wind energy at all speeds, at all wind speeds, especially lower wind speeds, and more sunlight hours per day without any need for a tracking mechanism for the sun. It takes advantage of intermittent variations in sun and wind. And the quote here is kind of whimsical. Quote, "It works come rain or shine. When it's not sunny, it's windy. And when it's not windy, it's sunny," quote unquote. Or at least such situations can happen. And this also offers an opportunity for these uh, renewable power campuses to be closer to cities, for nature and wildlife green belt amenities closer to cities, fewer bird and bat strikes compared to large spinning horizontal axis wind turbines. It can be closer to select cities with lower average wind speeds, and it can offer greenbelt spaces. So you can pause this and take a look at it, and we'll go on to the next slide. Well, this one was written and submitted on August 9th of 2020. And the seeker here, or the sponsor, is looking for new applications for their product, powdered polysulfate, which I believe is a salt that they extract from around the Dead Sea area in Israel. So I was very interested in this, and my title of my proposal was New Polysulfate Applications for the Green Energy Market, Eutectic Phase Change Materials, or PCMs, and Desiccant Coolants for heat storage and temperature control in buildings. Polyhalite is a hydrated sulfate mineral that consists of potassium, calcium, magnesium, and it is a natural evaporite mineral formed from mineral-rich brines that precipitate in ancient marine, lake, and lagoon salt sediment basins, such as the Dead Sea area. It is used directly as a plant crop fertilizer. It's really rich in potassium, with the additional benefit of very low chloride concentrations. Potassium and magnesium are really good plant nutrients. They're present as sulfate salts in good proportions. And what the sponsor here is looking for is new applications for the polysulfate product in the renewable or green energy markets. So what I came up with is eutectic phase change materials, PCMs. And what that does is, in physics, these can be used as a low temperature heat energy storage phase change material, or PCM. It's like Glauber's salt, and Glauber's salt is a sodium sulfate hydrated salt called sodium sulfate decahydrate. So I'm thinking that maybe the polysulfate material could be used or experimented with as a eutectic mixture in order to be experimentally combined in certain ratios to fine-tune the melting point of the mixture so that there's a desired temperature range where it absorbs and it releases heat as a heat storage material for building temperature control. And I think that polysulfate is a candidate for investigating such um, PCM design opportunities in eutectic salt mixtures for thermal energy storage and building temperature control. Thanks for listening. If you have any questions, give me a call or contact me by my YouTube channel or Facebook or X platform. Have a good day.